Hi. All right, guys. Welcome back to this school year. I figured since we have a quiz coming up that I would have another review session online. I'm holding this review session not from the auxiliary dining hall, but from my house. So I guess welcome to my house. All right, we're going to jump right in. Remember, on this quiz, we're going to cover three important topics: electron configuration, chemical and physical change, and chemical and physical properties. So let's begin with electron configuration. So one of the important things to remember about electrons is that they're found on the outside of an atom, and there's a lot of space in between them. Electrons are arranged not evenly around an atom, they're arranged in layers. And we call these layers shells. So right next to the nucleus here, we have the first shell. The first shell holds 2 electrons. After the first shell, we have the second shell. The second shell holds 8 electrons. After the second shell, we have the third shell. The third shell also holds 8 electrons. So electrons are arranged in these shells, and each of these shells has a maximum number of electrons. A moment ago, I already told you how many each shell can hold. The first can hold 2, the second can hold 8, and the third can also hold 8. They don't always have to fill all the shells, but whenever the shells are being filled, we always start with the shell closest to the nucleus first. When these 2 electrons are filled, then we go on to the next shell. When this shell is full, we go to the next shell. Electrons always fill near the nucleus first. The first shell is always filled first. That's how it works every time. All right. So another important topic when it comes to electrons that we've been talking about are valence electrons. Now those are the electrons on the outside of the shell. So what I mean by that is any electrons that are on the outside shell, like here, this is the outside shell. The electrons on this outside shell are the valence electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons in this atom. All right? The valence electrons are the electrons on the outside. All right, let's keep going. So I want to look at least one more electron configuration before we move on, okay? So for these electron configurations, remember you always want to write the number of protons in the middle first. In these cases, these are nice illustrations, so they don't have the protons drawn or written in. But when you guys are drawing these at home, remember to write the right number of electrons and the right number of protons. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So we'd want to write 8 protons in the middle as well. So looking at this atom here, we know that we have 1, 2, 3, 4, 5, 6 valence electrons. We have the valence electrons on the outside. Okay? So keep that all in mind for electron configurations. Be able to draw these guys. Remember, always start with your nucleus and then draw the electrons going out. And if I ask you a question about valence electrons, those are just the electrons on the outside. Okay? So, that being said, let's move on to another subject. By another subject, I mean more chemistry, and we're moving on to chemical and physical changes. So a physical change is a change that alters the form of something. That means it alters what it looks like. But it does not change it into something else. So we've discussed a lot of examples of this. The ice cream melting would be a physical change because the ice cream does not change into anything else. It's ice cream as a solid and it's ice cream as a liquid. It doesn't change. It's ice cream either way. Slicing bread is a physical change. We're making the bread look different, but it's still bread. Same thing with blowing up a balloon. When you blow up a balloon, it starts really small, and then you push a lot of air into it, and it becomes bigger. So it looks different. But just because it looks different doesn't mean it's something new. A chemical change, on the other hand, it looks different and it changes it into something else. This aluminum here is reacting with mercury, so it's changing into something else, and you can see it become something else. You can see it change. It's not the same anymore. It's chemically reacting. When it comes to bad fruit or rotten fruit or old fruit, you can taste the difference. One side tastes fresh, and when it gets old, it chemically changes into something else. This brown side that doesn't taste as good anymore. A good example is old milk. Old milk does not taste good anymore, and it's because it's gone through a chemical change to change it. Now another example is rust or burning wood, or this nice chemical reaction here that you see. Something is definitely changing it. So like I've said in class, there's 5 signs of a chemical change. The first sign change is a color change. See right here? Color. If you see color, that's a chemical change. A chemical change is happening. If you see a precipitate form, that's a chemical change. Remember, a precipitate is a solid that forms when you mix together two things. Here you see these two liquids being mixed together and making a solid. Here you see two liquids mixing together to make a yellow solid. The third sign is gas production. If your two things being mixed together make a lot of bubbles, that's a sign that a gas is being made. If a gas is being made, it's definitely a sign of a chemical change. Another sign of a chemical change is a temperature change. If something is changing temperature, if it's getting colder or if it's getting hot, that's a sign of a chemical change. If it's catching on fire, it's definitely getting hotter, so it's definitely a sign of a chemical change. And finally, if it's giving off light or if it's giving off smell, that's changing its property somehow, and that makes it a chemical change. So our 5 signs of chemical change: we have color change, we have precipitation, we have gas production, we have temperature change, and we have a change in property like giving off light or giving off a smell. Then finally, our third item that will be asked about on the quiz are physical and chemical properties. Now, physical properties do not change what the object is. Chemical properties tell you the types of changes these things or these matters can undergo. So a physical property, or measuring or observing a physical property, will not change the identity of what we're measuring. We can use this to separate mixtures. And we have a lot of different examples when it comes to physical properties. Here are the important examples to remember. Transparency. This is the property of light passing through. Glass is very transparent. My new socks here are not very transparent. So glass would be more transparent. Light would go through easier, which means we could see through it. Boiling point. This is the temperature when liquid becomes a gas. Every element has its own boiling point. Water has its own boiling point, 100 degrees Celsius. Alright, so Another two physical properties are the melting point. Every element melts, goes from a solid to a liquid. When it becomes a certain temperature, it goes from being solid to being a liquid. Brittleness is the tendency to break or crack. The more brittle something is, the faster it'll break. My ukulele is pretty solid. It won't break as easy. It's not brittle. My glass is brittle. This will break easily. Ductility, that's the ability to bend without breaking. You can bend something without breaking. My socks, very ductile. They can bend without breaking. My ukulele does not bend. It is not ductile. Elasticity, that's the ability to stretch or compress. In this GIF here, or some people say GIF, but in this GIF, the rubber band here is being stretched, and that means this rubber band is very elastic. Density is the degree of compactness of an object. How much matter is in an object. That's all density talks about. Density just talks about how much matter is in an object. The more matter, the heavier it is. So mass and volume is what you use to measure density. Mass is measured with a scale, and you use a displacement method or the formula method in order to measure the volume. So density equals mass over volume. That's the density formula. On the quiz, I will definitely ask you a math problem about this. I will give you the mass and I will give you the volume. Make sure you know how to find the density. I will tell you on the quiz, the mass is 6 grams. The volume is 3 grams. You have to know that you have to divide the 6 by 3 to give you the density. Make sure you remember the units. Grams per centimeter squared or grams per milliliter squared. Alright, chemical properties. It's a characteristic that indicates whether or not a substance can or has undergone a chemical change. So, some chemical properties are flammability, the ability to burn. Rusting. Rusting is a corrosive process. So that's when metal is broken down when it reacts with oxygen. Rusting is just one way of breaking metal down. Reactivity with vinegar is another way that things react. They can react with vinegar, and when they do, they normally produce a gas. So you see bubbles. So these are 3 chemical properties that you need to know. So this final part, these chemical and physical properties, they're not difficult to understand, but there's a lot of vocabulary that you're going to need to study. You need to make sure you know these 3 words, and you're going to need to make sure that you know what density is, you know what elasticity is, you know what ductility is, you know what melting point is, and brittleness, and transparency, and boiling point. Make sure you know what those things are. Alright? So you guys, that's everything on the quiz. I hope that has helped. If you need more help, find me after school on Wednesday and I'll be happy to help you out. Alright? So you guys, good luck on the quiz tomorrow, and I look forward to seeing you all in school tomorrow. Bye.